Hello, friends. We're back with episode 170 of the Our Weekly Highlights podcast. Gotta love those even numbers as we bump up the episode count here. My name is iamYannC, and I'm delighted you join us from wherever you are around the world listening on your favorite podcast player. This is the weekly show where we talk about the awesome resources that have been highlighted in this week's current Our Weekly issue. And I'm joined at the virtual hip, as always, by my awesome co-host, Mike Thomas. Mike, how are you doing today?
I'm doing well, Eric. I'm taking a look at the highlights this week. I see that there's no shiny highlights, so this couldn't have been curated by you.
Oh, the plot thickens. Oh, yes, it was. It was my turn this week. But rest assured, there is some good shiny stuff in there that we may touch on a bit later. But yeah, it was my turn on the docket. So as usual, I'm doing these curations in many different environments. Mike, you're going to learn this as your little one gets older. You got to be opportunistic when the time comes. And I was curating this either at piano lessons or swim practices or whatnot. But it ended up getting curated somehow. So we got some fun, great posts to talk about today. Never as short as a great content to draw upon. But as we always say in these episodes, the curators are just one piece of the puzzle. We, of course, had tremendous help from the fellow curator team on Our Weekly, as well as all the contributors like you around the world who are writing this great content and sending your pull requests for suggestions and improvements. So we're going to lead off. We're going to get pretty technical here in a very powerful visual framework. But I think this is a great insight into just how extensive R can be in many different domains that honestly you would least expect. But we're going to go to the moon a little bit here, Mike. Not quite literally, but we're going to see how R, with the suite of packages authored by none other than Tyler Morgan Hall, who is the architect of what we call the rayverse suite of packages for 3D and 2D visualizations in R. His blog post as part of this highlight here is talking about how to use R to produce not just images of the moon and other surfaces, but very accurate looking images with some really novel techniques that I definitely did not know about until reading this post. So I'll give a little background here, but when you look at graphics rendering, and you'll see this in all sorts of different domains, right? With like those CGI type movies or images or, animations, of course, gaming visuals and whatnot that have to do with some form of polygons. Little did I know at least, that the triangle geometric shape is like the foundational building blocks of many of these computer graphics, which gets you really long ways, but it's not as optimal when you have to render a surface that is on two different sides of a spectrum. First, maybe something that looks completely smooth, no artifacts, no, jagged edges or whatnot, or the converse of that, something that has unique contours, unique bumps, if you will, such as, say, the surface of the moon with its craters and other elevation changes. Now, there are two primary methods that Tyler talks about here that can counteract kind of the phenomenon of these triangles not really being optimal for this rendering. One of these is called subdivision, where in essence these polygons are subdivided further into micropolygons, often smaller than a single pixel, which means we're really looking at something small here, to help bring a smoother appearance with tweaking of certain parameters. And then on dealing with the converse of that, again, like dealing with bumpy surfaces or contours, you have what's called displacement of the vertices of these associated micropolygons to help bring this kind of artificial detail to the surface that, again, mimics what you might see in the real world with these contoured surfaces. And Tyler says that the rayverse suite of packages now have capabilities to handle both of these key algorithmic kind of explorations or rendering steps to make these more accurate looking visuals. And as I think about this, as we walk through this example here, I harken back, again, Eric's going to date himself here, to my retro gaming roots, where I remember very distinctly it was in the, early 90s, maybe mid 90s, that the local arcades started having these racing games that were not those like sprite-filled racing games like the yesteryear, like Outrun or whatnot. But I remember vividly Sega making a game called Virtual Racing, which was one of the first times I had seen in an arcade really robust-looking racing cars in 3D type perspectives, but you could tell they were made with polygons, and they were smooth. Some were smooth, and yet some were really jagged as heck when you would have crashes or sparks. And you could kind of see if you had a pause button in the arcade, you could see these little artifacts that appear that look like little geometric shapes. And in essence, that's what can happen when you render an image in the beginning. And he's got an example where he basically renders what looks to be a kind of like a cross between a sphere and a hexagon in a 3D contour, and then a cube, and then the R logo. But when you render this first of a few parameters that he does with one of his packages, you can see, yeah, they're low polygon shapes. They look like what I would see in that kind of first attempt at that virtual racing game. But then he starts to show example code, again, new to the rayverse, called subdivide_mesh, this function which lets you define just how deep you do this subdivision. And he starts with levels of 2, and then he re-renders the image. And now in this second image, you look, the left image, again, you want to look at this as we're talking through it if you have access to the screen. That first ball on the left looks like the Epcot Center or a golf ball on the golf course. You can see those little triangles split throughout, which is not what he wants. He wants to make this look completely smooth. So guess what? It's all iterative in these steps. He tries another subdivide mesh call with, first trying to make things look a little more smoother without going new subdivision levels. And it doesn't quite get the job done. They still look, a little bit off, but he's rounded out some of the edges to that aforementioned cube, but he's still got to go deeper. And basically, he finds this sweet spot of like subdivision levels of 5, which means this is upping the count on these little small triangle shapes that are composed in each of these images. And going from the start to finish of this, that added many, and I do mean many, additional triangles to each of these shapes as compared to what he started with. It's a huge increase, and in fact, it was a 1,024-fold increase in these number of triangles, which may not be the best for your memory usage in your computer, although there are no benchmarks around that. But I know from my brief explorations and things like what's a Blender for rendering 3D in Linux and other software, that as you make these shapes more complex, your computer's going to be doing a lot more work with that. So in the end of this example, he's got 3 versions of the rendered scene, what he started with, and then one in the middle, which is kind of like a compromise of like the subdivision levels and kind of moving some of these vertices around, and then the last one of using like all these triangles at once. The good news is that this shortcut approach in the middle, you can't really see a visual difference of the naked eye between that and the more complex version with the additional triangles. But the key point is that the rayverse packages support this, and you're going to have to experiment with it for your use case to get that sweet spot of the smoothness that you're looking for. So that was a great example how you want to give this kind of smooth appearance without those artifacts coming into play. Now we turn our attention to the bumpy or contour surfaces with, say, the moon as inspiration. And he mentions that this will be familiar to anybody who deals with GIS type data in the past with elevations. He has a nice render of both the moon image as well as Monterey Bay, where you can see the contours very clearly in the black and white images. And then he starts by drawing a sphere of what looks like the moon, but when you look at it, it just looks like a very computer graphic looking moon with like a shade on the left and light on the right, but you would not tell that's anything really. So then comes the additional kind of experimentation of, okay, how do we first figure out what is the current displacement information that's in that image so we can get a sense on what's happening here and how many pixels are being sampled to help do this rendering by default. So there are some handy functions that he creates to kind of get into this metadata. And he notices that in the first attempt, there's only about 0.09% of the pixels from that moon image are being sampled to produce this more artificial image. And that's why it's not looking like a moon at all at that point. So got to up the ante a little bit. Again, kind of like a iteration of this to figure out, okay, maybe I need to use more pixels to sample in this. Starts going from like 1.4% of them, still not quite looking right as you look at the post. Ups it further, and he's got a handy function called generate moon mesh that he kind of ups the levels one by one, and eventually he gets to a point where, hey, we're getting to what looks like the craters on the image, where about 5 or 6% of the pixels are being sampled. Still not quite there yet, but he ups the ante even more with this levels, and then he finds what looks like, a really nice looking moon, which ends up sampling about 89% of the pixels, which means that there is a lot going on behind the scenes in this image. And in fact, this would take up a lot of memory. And you can see there is there's a point of diminishing returns the more pixels you subsample here for this displacement. Not really a lot of change visually. So it ends up, he finds a sweet spot between not going to the extreme of like 2 million pixels resampled, somewhere in between. And hence he's got a really nice visual at the end where you can see it's getting much closer once he brings this back to the sphere shape. And there's a nice little phenomenon kind of towards the end where it looks like at each of the north and south poles of the moon, when you do it by default, it kind of looks like things are being sucked in like a vacuum. It's hard to explain. But then when he does applying the contour more effectively, you see that it just looks like any other surface on the moon with nice little craters and whatnot. As you can tell, I've been doing my best to explain this in an audio form, but what's really cool is that you can see kind of Tyler's thought process of when you have a problem he wants to solve with his rayverse suite of packages, these steps that he takes to go from start to finish, not too dissimilar to what I see many in the community do when they teach things like ggplot2. Start with your basic layer, start to customize layer by layer, bit by bit, until you get to that visual that you think is accurate given the data you're playing with. And in case of Tyler's visuals here, to closely mimic what you might see if you put your telescope out there and look at the moon at night. So again, a fascinating look to see the power of R in graphics rendering, which if you had told me this was possible 10, 15 years ago, I would have laughed in your face. But this is really opening the doors, I think, to many people making so many sophisticated images, not just in the 2D plane, but also in 3D, and really insightful walkthrough here. And you can tell when you read Tyler's writings just how much time and effort he's put into these packages to make all these capabilities possible, but yet with, logical and very fit for purpose functions, they'll be very natural, I think, to anybody that's been dealing with graphics processing in R in the past. So a lot to digest there, but again, I think it's a very fascinating field.
Eric, I couldn't agree more. I'm always fascinated by Tyler's work on this particular project. I think, when the rayverse sort of first came out, it was pretty revolutionary, I think, to the R ecosystem. We had ggplot, and we could do, a lot in ggplot and some of the other plotting packages that were available. But in terms of 3D visualization, animations, things like that, we never had anything like that, as far as I know. until Tyler came along. So these suite of packages in the rayverse, and in particular the ones that he's highlighting today and their new functionality are rayvertex and rayrender, are pretty incredible. I have tried to do some of this myself in the past. I think you can expect your laptop fan to hum a little bit as you try to do this. So get your GPUs ready especially if you're trying to add additional complexity and do some pretty in-depth things within these packages. But the fact that we can do this at all is absolutely incredible. And I loved the callback to sort of your early, 80s, 90s video game experience, because that exactly what a lot of this blog post reminded me of, as he leverages that subdivision levels argument in the subdivide mesh function. And you can sort of see how the pixelation just starts to smooth out as that number increases in terms of how many subdivision levels are being used. And it's almost, conceptually like following video game graphics from the 80s, 90s to the 2000s, as you sort of get away from these triangles and the pixelation into something that looks, much smoother. And to the naked eye, you really can't even see the pixelation at all. Great summary by you. I'm not sure if there's a whole lot more to add to it. It's an incredibly visual blog, so it's difficult for us to do it justice on the podcast here. So please take a look at it yourself. Even if it's not a domain that you spend a lot of time in, 3D visualization, I think you'll still find it fascinating.
Yeah, and it does remind me there is ripe opportunities that we often see shared on social media from time to time. They'll call it like accidental art, when you're trying to do a neat plot, but yet it doesn't come quite out right, but yet it's so interesting to look at, you want to post it anyway. These things are ripe for accidental art, especially if yours truly is the one coding it up. But I do think as you look at the evolution of these images, back to that racing example, it's like, when I saw that virtual racing game back in the early 90s, and again, you could tell it was like Sega's, first real attempt at making somewhat performant polygon renders. And then it was like a couple years later, those of you remember that Daytona USA racer game, it looked real. Like everything was smooth, everything was sharp, everything 60 frames per second. That is like, you can have that same transformation as you play with these displacement parameters, and again, the contour parameters. It's fascinating. It's absolutely fascinating. And who would imagine R could be an engine for graphics like this? And I've been following on social media kind of the other side of the spectrum, where it's a slight tangent here, but Mike FC, aka Cool But Useless, has been making all these packages that help him make sprite rendering even more easier in R itself. And it's like, my goodness, we could make almost any type of game in R now. It's just a matter of time, really.
Absolutely. It's incredible stuff. Incredible stuff. And I do remember Daytona USA very fondly. How much fun was that?
Oh, lots of quarters are spent in that one. And then, of course, the computer racers would just eat my lunch. But that was part of the design, to get your money back in those days. So we're going to shift gears quite a bit here to get into more of the data side of things, because there are some really promising developments in some of the ecosystems that Mike and I have been speaking really highly about in recent episodes of our weekly highlights. And in our next highlight here, we're going to go back to now getting a lot of traction, so to speak, the DuckDB paradigm, the DuckDB database that just got supercharged with a new plugin and a new capability of using a service that's new to us from the R side of things. So, and it happens to be called MotherDuck, and that's an awesome name. But Mike, what is this all about?
So MotherDuck is a way to run, as far as I know, it's sort of a whole cloud-based data warehouse system or platform from the developers of DuckDB themselves, that allow you to not only store data in the cloud, but to also run DuckDB itself in the cloud, so that you don't need DuckDB installed on your own laptop. You just need to be able to authenticate into your MotherDuck account that you have, and you can run serverless cloud-based analytics using DuckDB but not needing anything installed on your own laptop, which is really cool. Besides, the packages to authenticate into it. So currently, and one big component of this that's noteworthy that I think we should touch on is DuckDB just released version 1.0.0 on June 3rd. So this is incredibly exciting, for the folks that have been following this project, for the folks that have been working on this project, that we have a first sort of major release of the project. And it's, I think it's a framework that we've seen play out a few times, in the data science ecosystem, where a team will develop an amazing open source framework or functionality. I think we've seen this with the DBT package. If you're familiar with DBT's software, that I think allows you to do more versionable ETL. They also have, I believe, a paid offering of that as well. I know the team at iamYannC sort of has some similar things going on. And it looks like the DuckDB team obviously has this incredibly powerful open source software that we can now use for doing some pretty incredibly efficient ETL and SQL querying on large data sets in like no time at all. But they've also built out, obviously, a sort of privatized side of the business that allows them to hopefully make money and to continue to enhance DuckDB itself. And that's this MotherDuck offering that we're talking about here. So there's pretty good documentation on how to connect to your MotherDuck service from Python, but it looks like there's not necessarily any documentation out there yet on doing this in R. Although the author of this blog post, Novika Nakov, notes that it should be pretty straightforward to do so if you follow sort of the Python framework and just adopt it, leveraging what we know about how to connect to DuckDB databases using R. So that's what Novika is doing in this blog post. He is outlining how you would go about connecting to a MotherDuck instance from R, leveraging R441 on Linux with DuckDB version 1.0.0. It's pretty easy to connect to a DuckDB database, an in-memory database, and he has a nice little code snippet of how to do this, how to populate that database using a data frame, and then how to query it using SQL syntax. And it also notes that we do have the new duckplier package that would allow you to do this in a more dplyr-like approach, as opposed to having to write a SQL string in your dbget query argument. But for the purposes of this blog post, we're not going to explore duckplier. So Novika details the Python approach first to connecting to MotherDuck, and really it's pretty simple, and this MotherDuck extension actually comes native to the Python DuckDB package, and it's just a little one-liner essentially that allows you to connect to your MotherDuck instance. You'll automatically get a notification in the terminal telling you what URL you should enter in your browser to be able to authenticate to your MotherDuck service, and then you're essentially good to go from there. In R, it's a little trickier. The syntax looks pretty similar. It's a one-liner to try to connect to your MotherDuck instance. But one of the first things that you have to do is actually from the terminal, I think, write a little bit of code to create a local database that's called MD, or shorthand for MotherDuck. So the reason that you have to do that, as Novika posits, is that the DuckDB package for R doesn't automatically figure out that it needs to load this additional MotherDuck extension the way the Python package does. So you have to sort of do that yourself. But again, Novika has all the code for us to do that here, and it's fairly straightforward. You have to run a db execute command to load this MotherDuck extension, and then you're pretty much good from there to be able to connect to your MotherDuck instance and write your SQL queries that are going to execute in the cloud as opposed to locally. So it's a fairly straightforward blog post. It's really, really helpful, I think, for those of us that are exploring DuckDB and want to try out MotherDuck. I will note that there's a free tier of the MotherDuck offering that gives you, I think, 10 gigabytes of storage, up to 10 compute unit hours per month, which is probably a lot. I'm not sure, we know how fast DuckDB queries execute.
That's right.
Most of my DuckDB queries, even on Parquet files, that are gigabit 1 or 2 gigabytes in size will run in maybe a second or two, and there's no credit card required for this free offering. So there's no reason to not try out this MotherDuck service if it's something you're interested in. And if you need to go up to the paid tier, it's $25 a month per organization, I guess not per user, which is pretty incredible. If you're an organization that wants to leverage this MotherDuck service, and that gives you 100 gigabytes of storage and 100 compute unit hours per month, which unless you're doing some pretty crazy stuff, I can't imagine that you would hit that. So I think it's a very sort of generous price point that we have here, and obviously it's amazing that we have this free tier that allows you to try it out first, if you want to, and maybe that's all you need as well. So pretty incredible, great walkthrough by Novica on how to use this in R, because up until now I don't think there's been any documentation on how to connect to the MotherDuck service from R, and it seems like there was a little tricky hack that he pointed out that's definitely going to help those of us who want to try this out ourselves, probably save us a lot of hours. So we're very grateful that he went down that rabbit hole for us.
Things are moving pretty fast in the DuckDB ecosystem, that's for sure, ever since 1.0 was released. And I do recall having to do some extension installation in my explorations a few weeks ago, where I had to install a couple extensions, one of which was to help interact with object storage in AWS. It didn't come by default. But yeah, it's a similar syntax with what Novica outlines here in this post. And yeah, I guess I'm interested in exploring MotherDuck to just see, on a very basic basis, just how it plays in my workflows. One thing I'm immediately thinking of, Mike, is that if you're an organization or whatever, small or big company, and you want to leverage DuckDB as your database backend for things like Shiny apps or whatnot, it sure does seem like having that hosted in a data warehouse would be an intriguing idea to help offset some of that storage footprint from you to that vendor. Of course, we were remarking in the pre-show that you want to at least have like a couple plans, if you will, of where you host these files, because you never know what can happen. Hashtag just saying. But in any event, what's nice about this service, I think they have some examples I was perusing yesterday where they did hook up a couple, it was either observable notebooks or some other custom web apps with, say, the New York City taxi data, and doing simple queries on that and some drop downs. And it was, as you said, blazing fast with these queries to get the results back to the browser, and not making your browser do all the data munging itself. It's going to, do that on the server side. And it does look like they're also exploring interactions with, wait for it, WebAssembly too. So there's going to be lots of interesting, I think, applications to play here. And again, I'm intrigued to see where this goes in the future.
Absolutely, me too. It's an exciting space to watch. I've only dipped my toe in it. One really cool thing about the RStudio IDE is if you do have a .SQL file in your RStudio IDE, every time that you save that file, if you have a more recent version of RStudio, it'll re-execute the query for you and show it up in sort of the query output pane of RStudio. And that works great in DuckDB as well. I was playing around with it against a parquet file, just editing my DuckDB query and seeing the results come out real time without even having to highlight the code and click run or anything like that. It's pretty incredible.
All these save so much time when you add it all together. That is for sure. Did you say parquet files, Mike?
I did, Eric.
You sure did, man. That's a perfect segue to our last highlight today, because honestly, one of the building blocks that we have been, espousing the praises of in many recent episodes is Parquet as kind of this next generation data storage format. And certainly when you hear us talk about, a lot of the use cases are when you have a collection of large data that you can do pretty, sophisticated group processing with, so you can get really fast and real-time kind of analyses being executed on it. But that's not the only use case, because our last highlight here is an awesome update to the nanoparquet R package created by Gabor Cesardi, a software engineer at Posit, and his latest blog post talks about some of the key updates to this package and some of its use cases. So Mike, why don't you walk us through what's new here?
I'd be happy to, Eric. You know that I am one to sing the praises of the Parquet format and everything around it. So very excited about this nanoparquet R package and the 0.3.0 release that Gabor worked on. I believe Hadley may have worked on it as well, and some others on the tidyverse team at Posit. So one of the reasons that they created the nanoparquet package is that they wanted to be able to interop with parquet files without necessarily needing some of the weight that comes along with like the arrow package, because the arrow package does have a fair amount of dependencies on it and it can be a little heavy to install. So one of the things about this nanoparquet package is that it has no package or system dependencies at all, other than a C++11 compiler. It compiles in about 30 seconds into an R package that is less than a megabyte in size. It allows you to read multiple parquet files, which is in a traditional sort of data lake structure, very, very common, with a single function, sort of like what we have in the readr package. I don't know if this is little known or if it's well known, but if you just point that to a directory instead of a file, it will read in all of the files in that directory, assuming that they have the same schema, and essentially append the data together into a big data frame. And that's the same thing that the nanoparquet's read parquet function will do for us. It also supports writing most R data frames to parquet files, and has a pretty solid set of type mapping rules between R data types and the data types that get embedded as metadata in a parquet file, which is, again, another reason why, parquet format exists, and I think was another part of the motivation for this nanoparquet package, that it gets a little bit of a reputation, the parquet format, for only being for large data sets. Like, you only want to use parquet file format when your data is big. And I think what Gabor's trying to argue here in this blog post, and that I would agree with, is that that's not necessarily, the case. And I think that anyone can make a case for leveraging the parquet file format for storing data of any size. And one of the, I think, big reasons for that is the ability to not only have the data in the file, but also metadata around the data, including the data types, such that when you hand that parquet file off to someone else, they don't have to, in their code, the way we used to do when we read a CSV in and define what the data type for each column that's coming in. You don't have to do that because it's embedded in the file itself. So we have a lot more safety around reading data frames and writing data frames, and ensuring portability, not only between languages but between users, essentially, so that what you see is what you get. So I think that's really helpful. We know that Parquet is performant and typically a smaller size than what you would store in a traditional delimited type of file, which is helpful as well. And there's additional things like concurrency. A Parquet file can be divided into row groups so that Parquet readers can read, uncompress, and decode row groups in parallel, as Gabor points out. So just a lot of, I think, benefits for leveraging the Parquet file format. And I think this is maybe one of the first blogs that I've seen make the case for the Parquet file format for small data as opposed to big data. So I'm super excited about the nanoparquet package, because I think that there are some particular use cases, potentially Shiny apps that I'm developing that are maybe reading a smaller data set where I don't necessarily need to leverage the whole Arrow suite of tools, and maybe I just need to read that data set in one time from a Parquet file, and the nanoparquet package might be all I need.
Yeah, I'm with you. I'm so glad they give, the spotlight not just to the typical massive, gigabyte data sets. I think what nanoparquet is doing here, again, great for the small data set situation, but I really like these metadata functions that are put in here too, because I think nanoparquet could be a great tool for you, especially being new to Parquet, getting to know the ins and outs of these files, knowing, like you said, the translation between the R object types and the Parquet object types in the data set. There are lots of handy functions here that maybe they are part of the arrow package. I just didn't realize it, but to be able to quickly have these simple functions to grab, say, the schema associated with Parquet, grabbing the metadata directly in a very detailed printout of, a nice tidy data frame of these different attributes. I think this is a great way to learn just what are the ins and outs of this really powerful file type. And of course, Gabor is quick to mention some limitations for this. He does say he probably wouldn't recommend using this to write large Parquet files because this has only been optimized for single-threaded processing. But with that in place, I still think this is an excellent way to kind of dive a little bit or really deep into what are the ins and outs of Parquet. And then when you're ready for that transition, say, to larger data sets, he obviously at the conclusion of his post calls the Arrow project out as well as DuckDB out. So you've got it all leads somewhere, right? Your situation may be that nanoparquet is going to fit your needs, and that's awesome. More power to you. And then as you escalate your data sizes, then you can still use Parquet. You're just maybe transitioning to a different package to import those in or to write those out. So I think it's a great introduction piece, as well as, I'll be honest, I'm putting on my life sciences hat for a second. I would absolutely love to use Parquet format as opposed to a certain format that ends in 7B that. You know what I'm talking about, those out there. This would be a game changer in that space.
I mean, the word Parquet just sounds a lot smoother than, SAS 7B dat. It sort of sounds like, I don't know, R2D2 or I don't know,
Well, at least R2D2 had a personality.
Oh, goodness. Let's switch quickly, and one acknowledgement that Gabor makes in this blog post that I do want to highlight, just for the sake of talking about how small of a world it is out there in the data science, data engineering community, is nanoparquet is actually a fork of an R package that was being worked on called miniparquet. And the author of miniparquet, that R package, was Hans Muelsen, who is the founder of DuckDB.
Well. It all comes full circle, doesn't it? Oh, this is, what a fascinating time. Awesome call out.
And I believe Hans will be keynoting at PositConf this year, if I'm not mistaken.
You are correct. Yes,
as
I'm
well
really
as
looking
like
forward
every
to
other data science conference, I think, this year.
He's been a busy man for sure.
Deservedly so.
Yeah, lots of momentum here, and again, it's great to see all these frameworks and R now being a great beneficiary to this amazing work and giving us the tools, multiple tools to interact with these systems. Wherever, like you said, we have multiple packages that interact with DuckDB itself, now multiple packages that interact with Parquet. You've got lots of choice here, and yeah, the time is ripe, as it does seem like we're moving on to like these newer formats, these newer database formats, that the sky is indeed the limit here. And thanks for writing that ship. I was about to go on more rants about another format, but we're going to keep it positive here, because this issue has much more than just what we talked about here in the 3 highlights here. I had lots of fun looking at the new packages, the updated packages, and much more. So we'll take a couple minutes for our additional finds here. And yeah, going back to the sports theme for a second, now that we have a lot of interesting tournaments going on right now in the world of soccer and football, you might want to visualize some of those, head-to-head matchups. And I've got the package just for you for that one, a new package called Brackets, offered by Vera Lemlimput, who you might be familiar with. She's been a frequent contributor to the Shiny community in many talks and presentations. But Brackets is an HTML widget that lets you very quickly visualize the bracket of a tournament. And I could see lots of use cases in the world of sports analytics for darn sure. But the ever fascinating part of this package is that it was actually built during a course that Virla teaches about supercharging your HTML widgets, which is part of the Athletics platform that she recently joined alongside David Grandjean. So they've been both hard at work on some of these courses about Shiny and HTML widgets. And yeah, brackets is one of the products of those courses. But yeah, when I get back to doing more sports analytics in the future, I think I'm going to put brackets in my Shiny app just for fun alone. But I could see lots of cool utility with that.
That's a great call out, Eric. And when I saw that, really, I guess, clean way to visualize, tournament brackets, I don't know, I thought it was super cool too. So I'm very glad that you shouted it out. I am not surprised. I did not realize that Virla is the one who put that together. And I'm excited to see more from that, especially as we continue to dive deeper into a couple tournaments in my favorite sport, soccer or football for the rest of the world. A lot of bracketology going on these days, so looking forward to more in that area. One call out that I want to make is Frank Harrell's blog, Statistical Thinking, has a new slide deck that he gave as a presentation at the International Chinese Statistical Association Applied Statistics Symposium in Nashville recently. And the talk is titled Ordinal State Transition Models as a Unifying Risk Prediction Framework. And he presents a case for the use of discrete time Markov ordinal longitudinal state transition models. If we can pack all of those words into the same sentence, and really the purpose there is estimating risk and expected time in a given state. And it's really, in the vein of clinical trials in that area. But I took a look at these slide decks, and state transition matrices and models are something that I deal a ton with in banking and financial services, because most loans, banks have a particular rating assigned to that loan based upon how risky it is to the bank, the likelihood of that loan going bad, essentially, or likelihood of repayment or the borrower not repaying it. And, they continue to reevaluate that state that loan is in. It could be monthly, it could be quarterly, it could be at some longitudinal time horizon. And then we want to take a look at how the volume within that loan portfolio shifted from one state to another across a given time period. So I have an R package out there called Migrate that is due for some updates or due for a re-release on CRAN. We've had some work done on it recently, but I just need to push it over the hump. So I would check out these slides if you're interested in this type of stuff. But mostly I'm calling this slide deck out as a call to action for myself to get some work done on the Migrate package and hold myself to it out in the public here.
Hey, our weekly has many benefits, right? Making you do more work. That's awesome.
Yes, but great set of slides by Frank.
Yeah, Frank did a terrific job here. And you talk about small world. I remember a lot of the mathematical notation and the concepts here, because my dissertation very much had a component of theory around state transitions and competing risk methodology and whatnot. So I'm getting flashbacks of writing that chapter in my dissertation. Was not easy back in those days. But Frank is one of the great thought leaders in this space. And yeah, it's great to see him sharing this knowledge in many, many different formats and many venues. And there's so much more knowledge you can gain from the R Weekly issue. Again, we could talk about it all day, but I wish we had that time. But we're going to invite you to check out the rest of the issue. Where is it, you ask? Oh, you know where it is. It's at rweekly.org. It's right here on the index page, the current issue, as well as the archived all previous issues if you want to look back to what we talked about in previous episodes. And also, this is a community project. Again, no big overload company, funneling down our vision. This is all built by the community, but we rely on your contributions. And honestly, the easiest way to do that is to send a pull request to us with that great new package, blog post, presentation, resource, call to action, you name it. We got a section for you in the R Weekly issue, all marked down all the time. Just send us a pull request and curator of that week will get it into the next issue. And also, we want to make sure we hear from you as well. We, of course, love hearing from you. We've had some great shout outs recently, and hopefully you keep that coming. The best way to get a hold of us is a very few ways. We got a contact page linked in the episode show notes. You can directly send us a message there. You can also find us on these social medias, where I am mostly on Mastodon these days with at our podcast at podcastindex.social. I am also sporadically on X, Twitter, whatever you want to call it, with at the Rcast, and on LinkedIn. Just search for my name and you will find me there. And Mike, where can the listeners get a hold of you?
Sure, you can find me on Mastodon at Mike_Thomas at fosstodon.org, or you can check me out, see what I'm up to on LinkedIn if you search for Ketchbrook Analytics, KETCHBROOK.
Very nice. So we're very much looking forward to that new package release when you get that out the door. Hopefully that'll be a topic of conversation in a future episode. But yeah, I think we've talked ourselves out. We're going to close up shop here for this edition of our Weekly Highlights. And hopefully we'll be back at our usual time. We may or may not, because this is a time of year where vacations are happening. But one way or another, we'll let you know.